All right, so what else can we do with Fibonacci numbers? Remember, we're still needing to pause often, rewatch, rewind as much as necessary. So we can actually express each non-Fibonacci number as a sum of non-adjacent, that means not next to, Fibonacci numbers. So let's look. So our first non-Fibonacci number is 4. We can express that as 1 plus 3, which are two non-adjacent Fibonacci numbers. How about 6? We can write that as 1 plus 5. 7 as 2 plus 5, 9 as 1 plus 8. So go ahead and give it a try here. Pause the video here and fill in the rest of this chart, rewriting each natural number as a sum of non-adjacent Fibonacci numbers. Press play when you're ready to see the solution. So did you notice any patterns? So here's the thing. We can actually do the following. We can write down a natural number. We can find the largest Fibonacci that does not exceed it. And that Fibonacci is the first term in our sum. Then we subtract that Fibonacci from our number and look at the new number and find the largest Fibonacci number that does not exceed this new number and continue the process. Let's try it with 19. So let's try it with the number 19. What's the largest Fibonacci number that does not exceed 19? So remember our Fibonacci numbers, good to have them handy. Okay, so the largest one that does not exceed is 13. So the largest number that does not exceed is 13. That's the first number in our sum. So we don't know how big the sum is, but we know that 13 is going to be the first number. Now, subtract that Fibonacci number from your number. So 19 minus 13 gives me 6. Find the largest Fibonacci that does not exceed 6. Okay, so that's 5. That is the next number in my sum. And then I'm going to subtract. 6 minus 5 gives me 1. What's the largest Fibonacci? Well, it's actually 1. So go ahead and give it a try with number 38. Press play when you're ready to see the solution. And there we go. So what else can we do with Fibonacci numbers? Let's play a game. So start with a pile of sticks. So maybe it's pencils, pennies, straws, toothpicks. Person 1, so you got to get a friend here. Person 1 removes any number of sticks, at least one but not all from the pile. And then person 2 removes as many as they wish with the restriction that they must take at least one stick, but no more than 2 times the number of sticks the previous person took. And the player who takes the last stick wins. So let's just say we had a pile of 20. Pile of 20. And you can start with whatever number if you want. And then person 1, let's just say they took 5. So they have to take 1 but not all. And then person 2 can take as many as they wish with the restriction that they must take at least 1, but no more than 2 times what the other person took. So 1 to 10. Okay, that's their choice. So maybe so the pile was 20, someone took 5, so now the pile is 15. So maybe they take 6. So now the pile is 9, and person 1 can now take between 1 and 12. And so maybe they take, the person who takes the last stick wins. So maybe they take 9, and then they won, right? They're happy. So you're going to go ahead and play that game a couple different times. Start with different numbers of sticks, build a strategy, think about what you notice. You can play against yourself if you want, really just give it a shot and then press play when you're ready to see how to win this game. So we can actually use Fibonacci numbers to win this game. First, you want to make sure that the initial number of sticks is not a Fibonacci number. So that's step 1. So you start with any number that is not Fibonacci. So don't start with 5. Now, you also want to be person 1 and you just pick, anybody maybe you want to see lose. Maybe you want to win a bet. Pick person 2. So the secret is to write the number of sticks in the pile as a sum of non-consecutive Fibonacci numbers. So what we did earlier. So you've got your pile of sticks, maybe it's 19, and you know that that sum is 13 plus 5 plus 1. So you're going to figure out the smallest Fibonacci number, so in that case it would be 1, and remove that many sticks on the first move. Now, no matter what they do, you just keep repeating the process. So once they pick their sticks, you count how many are left, write it as a sum, and remove the smallest Fibonacci. And no matter what happens, we'll be able to remove the number of sticks and win no matter what. So go ahead, try this game out, give it a shot, and that concludes section 2.2, numerical patterns in nature.